Here's an exercise that's actually a lot easier than it looks. 7.3, page 324, exercise 6, and we'll do D from exercise 6. Exercise 6 asks you to write a system of linear inequalities for each graph. So it gives you these shaded areas that are all kind of awkward and weird looking, and it asks you to write the system of linear inequalities that'll give us this as a solution set. So let's look at D. I've photocopied D here on a larger piece of paper. And here's the thing. If this is the solution set in the shaded area, it is bounded by a series of lines. We can draw those lines in. I'm going to draw this line in here. And I'm going to draw solid lines because, well, why not? Because they're all solid lines here. And that gives us a hint, actually. That means that everything is going to be either a greater than equal to or less than or equal to when we draw the inequalities. So we'll keep that in mind. So there's an orange line. Let's draw the green line in. These are the boundaries, the bounds of the solution set. There's a green line. Let's get a blue line in there, which is down here. And a pink line over here. And so we have 4 lines that form the boundaries of the solution set. Now, when we need inequalities that represent each of these lines. So if we had to draw an equation of each line, it would be relatively easy. I'll just do the orange equation here. You can see here that the y-intercept is -2 and the slope appears to be 1. And so we would know this line is y equals x minus 2. And that's the equation that represents that line. Now, we would like the upper half plane with respect to the orange line, so that therefore would be that y is greater than or equal to x minus 2. And this inequality then, greater than x minus 2, is all this stuff on the upper half plane defined by the orange line. Let's look at the green line. The green line, if it's an equation, crosses the y-axis at +2, and you can see it's got a negative slope of -1. So as an equation, that line is y equals negative x plus 2. And that would be just the line, but we would like the bottom half plane, because this is all in the bottom half plane with respect to the green line, and therefore it should be less than or equal to negative x plus 2. So there's the orange and the yellow. This is part of the system that we're looking for, and this is part of the system that we're looking for. So we just have to do the pink and the blue. The blue is super easy. The blue is simply y equals -2. That gives us the line. Now we would like everything above that, so the inequality that we're looking for is y is greater than or equal to -2. And that gives us everything in the upper half plane with respect to the blue line. So this is part of our system of inequalities that gives us the shaded area. And the last one's the pink one. The pink one, like the blue one, is a simple x equals. In this case, x equals -2 would give us this line, and therefore if we want everything in the right half plane with respect to the pink line, it's x must be greater than or equal to -2. And that would be the last inequality that forms our system. So the 4 inequalities then are x is greater than or equal to -2, y is greater than or equal to x minus 2, y is greater than or equal to -2, and y is less than or equal to -x plus 2. These are the 4 inequalities that we have boxes on. Any coordinate within the shaded area, if plugged into any or all of these inequalities, they would be true. This is the solution set for this system.